as I mentioned, we are having the fundamental set of solution. Fundamental set of solution. Number one, they are solutions of the different. Say here we take here the fundamental set of solution as say y1, y2, and y3. This is one different solution. Number one, the set of solution y1, y2, y3 is solution of the differential equation. Number one. Number two, these are y1, y2, y3 is linearly independent. Then if this is true, then we can write the general solution for this one. That's our linear combination or superposition. We can say y, the general solution is C1 y1, C2 y2, and C3 y3. If we have to prove that this given set of solution is fundamental set of solution of the differential equation, first we have to check that they are the solution of the differential equation, number one. Number two, then we check they are linearly independent by using the Wronskian. And then number four, we just write the general solution. I give you the example for this one. I want to show that this function y1, y2, y3, that's y1 equal to x, y2 is equal to x squared, y3 equal to x cubed, form the fundamental set of solution for given differential equation and find the general solution. So they form the fundamental solution. Number one condition is they are the solution of the differential equation. Number two, they are linearly independent. We check these two things. If they are true, then we say we can write the general solution. So number one, so we take here y1, that's my x, y dash is 1, y double dash is 0, y3. We substitute in differential equation here. We get here 0, minus 0, then here plus 6x plus 6, because we have here y dash equal to 1, and then we have minus 6x, and this equal to 0 is true. Then we take number 2, this was our number one solution, and take number 2, y2. So my y2 is equal to what? Is equal to x squared. So I write here y dash is equal to 2x, y double dash is equal to 2, y triple dash is equal to 0. Substitute in my differential equation, I get here 0, then here y double dash is minus 2, we get minus 6x squared, then here y dash is equal to 2x, we get here plus 12x squared, and then here minus y dash is minus 6x. So we are having here 6x squared equal to 0. We can see we are having the value here is minus 6x squared, and here minus 6x squared, and this one is plus. So is also correct. This is solution of this one. We take number 3, and number 3 is x cubed. So say here number 3, we are having here y equal to x cubed, then y dash is equal to 3x squared, and y double dash is equal to 6x, y triple dash is equal to 6. Substitute in differential equation, and we can see here this is 6, put here y double dash 6x cubed, then here is y double dash is 6x, substitute 6x, we get 6 into 3 is 18, minus 18x cubed, then is y dash is 3x squared, substitute 3x plus 18x cubed, and then we having here y is equal to x cubed, we get here minus 6x cubed. We calculate this one, this is equal to 0, and you can see here we're having here 6x cubed minus and 6x cubed plus cancelled, this is minus plus is cancelled, so it's also the solution. So we say here y1 is equal to x, y2 is equal to x squared, y3 is equal to x cubed are solution of the differential equation. No, this was number one. Number one, we want to check that they are the solution of the differential equation. This was my number one. Number two, are they linearly independent? I calculate the Wronskian of f y1, y2, y3. As we said, we say that you find the determinant, and my determinant is here x squared, x cubed differentiate it. We get here 1, 2x, then 3x square. Then we differentiate once again. We get here 0, we get here 2, we get here 6x. Now we have studied already the determinant. We can open this one from the first column. We get having here x into determinant. We having 2x, the minor of this one, 3x square, 2, 6x. Then we having minus 1. So this is plus, minus, and then this is plus. And we are having here, this is gone, this is gone. We get here x square, x cube. We get 2 into 6x. Then we have 0 into cofactor, that will be equal to 0. So we solve this one. We get here x into 12x square minus 6x square minus. I get here 6x cube minus 2x cube. So I solve this one. We get here this equal to 6x cube, and then we are having here 4x cube, and minus is minus 4x cube, and we get here this equal to 2x square, and this is not equal to 0 when we having our real numbers minus 0. At 0 it is nullifies, is linearly independent. This here y1, y2, y3 are linearly independent. On the interval, R, we're having here minus 0. So that's number 2. Number 3, can we write the general solution? Yes, we can write the general solution. So the general solution will be y equal to c1 y1, that's c1x, plus c2x square, plus c3x cube, as on the interval R minus 0, not at the origin. So very important point that you can see here, this is not 0, but when take x equal to 0, then it's the origin. So we can't define the initial value problem at 0. That's because at 0, as we have a2 of x, remember we have the theorem an of x, x that must not be equal to 0, the highest order coefficient to get the solution of the initial value problem. So here this can't be defined at 0. So this is linearly independent. So the solution is true only on the interval where we don't have the 0 values. So I will put my notes in the description. As I mentioned before, there are many examples. It's not possible to do all the example in a video. So I will advise you that you also read more examples in my notes. Also there are the exercises, do exercises. Again, I would like to mention, if you want to learn mathematics, you can't learn it without solving the problems. So even you can make the effective use of the examples given in the notes. So you solve yourself, and then you compare your result with the solution given in the example, and that will help you to correct yourself, your mistakes, and improve it. Do the practice problem, inshallah you will get more. Inshallah we'll continue with more problem, more ideas in the next video.